For today, let's solve this standard inequality question using AMGM inequality. Given that A, B, C are positive, we are asked to show that the expression on the left, that is A squared over B plus B squared over C plus A plus C squared over A plus B is greater than or equals to A plus B plus C over 2. For those who have some experience in solving inequality, this question can be easily solved within one step using Cauchy inequality. However, we try to make the full use of AMGM inequality and challenge ourselves, see if we are able to solve it just using AMGM inequality. Please type the question before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
We'll look at each of the terms, hopefully get some useful result. So A squared over B plus C. We look at the answer here. We do not have any variable in the denominator. So it suggests that we need to plus B plus C so that we can cancel off after that using AMGM inequality. We may check that the equality holds in this case if and only if A equals to B equals to C. So when A equals to B equals to C in this case, this will be equal to A over 2. And this is 2A. So to make them the same, I have to divide by 4. So using this idea and AMGM inequality, we get this is greater than or equals to 2 of the product to the power of half. And this is A squared over B plus C, B plus C over 4. As you can see, B plus C can be cancelled off. Square root of 4 is equal to 2 and cancel with this. And what we have is just A because A is positive. Using similar argument, we have B squared over C plus A plus C plus A over 4 greater than or equals to B. And C squared over A plus B plus A plus B over 4 greater than or equals to C. Okay, so when we add up all the terms in the left hand side, then we will have, call this expression as J. Then we will have J plus A over 4 and A over 4, A over 2. Likewise for B and C. And for the right hand side, it is A plus B plus C. And this means that J greater than or equals to A plus B plus C over 2. If you enjoyed this video, please like, comment and subscribe. With this, we prove this inequality. Now there is an interesting fact to note that is, if we change this A squared to B squared and B squared to C squared, C squared to A squared, we'll get exactly the same result. Which means that if I have K equals to B squared over B plus C plus C squared over C plus A plus A squared over A plus B, using the similar argument, you'll know that K will be greater or equals to A plus B plus C over 2. Likewise, if we let L to be equals to C squared over B plus C plus A squared over C plus A plus B squared over A plus B, then we also have L is greater than or equals to A plus B plus C over 2. Each of these J, K, L greater than or equals to A plus B plus C. So now the question is, among J, K, L, which one is biggest, which one is smallest, and why? So if you have an idea, write it in the comment. That's all for today's lesson. I'll see you again next time. Bye bye.